And welcome to this first afternoon session. It's my pleasure to introduce Dan Klein from Valtech. Valtech is a new strategic partner of the CCIMI. And I really look forward to your presentation, Dan, which is on understanding AI and machine learning through user need.
Thank you. And well, good afternoon. Graveyard shift. And I feel slightly not worthy here because it's full of mathematicians and physicists and statisticians, and to be honest with you, I'm just an engineer, so I'm going to apologise now for not having much content. I'm joking slightly. Most of you in this room have probably never heard of Valtech, so for a bit of context, there's 3,000 of us around the world, 16 countries, and fundamentally the three things we do creative art direction and things like content creation, videos, all that sort of stuff. Then we do software engineering, and the last bit we do is data engineering, data science. And the capability for Valtech in that space is in London, and we serve globally. And one of my colleagues in the room, Jason, we serve that globally from London. And we have a satellite operation that's just started in Germany. But fundamentally, we have quite a big team, it's bigger than this now, of data people in London. And we do some quite interesting stuff. So I'm going to touch on that as I go through the talk. So yes, as Carola said, this is about understanding machine learning through user need. And I'm going to pivot slightly because this is a bit of a personal journey for me. Some of you know that when I graduated in '93, I graduated in this very specialist subject called information science, and I'd done Bayes and Markov, and I was interested in nonlinear control systems. There was only two places at that time that you could go with that specialism, and that was either aerospace or the security services. And as this picture probably alludes to, I landed up in aerospace, and quite proud of the fact there's a nonlinear controller running that tail, which I coded back in the 90s. It's a 7th order state space. It's quite interesting. Back in the day, it was completely revolutionary because the tail is very light. So I started there and sort of had a bit of a career. If I scroll forward 15 years now, after I've started in aerospace, I find myself using similar techniques, all the stuff I've learned, but I'm now protecting children online from abuse. And I'm worrying about, and I'm using, well, this is now 2006, 7, 8, I'm worrying about children and how do we find bad guys and stop them. So I'm thinking, okay, this is good, and the market's now taking off, and we've now got a bit of data science starting to happen. The likes of Facebook have just arrived, Google has been around about 10 years, and I think, well, okay, bit of a crossover. I'm going to take some of the frequency analysis techniques and I'm going to put them into a slightly adjacent market. And left-hand side, I file a patent with a couple of other colleagues, and we start looking at organised crime gangs doing copyright infringement and theft of very large quantities of theft of material. And we start getting involved with Virgin Media about how we deploy that. Mea culpa. Right, we screwed up. I personally got absolutely torched in the press. I got torched on Twitter, early days of Twitter, and I got torched by the Register because we didn't actually talk to anybody. We just thought, this is a really good bit of tech. It's really going to sort some stuff out. It's all anonymous. It's doing frequency analysis to find out where the bad guys really live, and we can shut them down. Population and the response of the media in particular hated it. Even though it wasn't interested in individuals. We weren't interested, never had been interested in individuals because it was illegal, still is illegal. There's a big mea culpa for me there because guess what? Having fallen flat on my face, you learn an awful lot when that happens. And a lot of this talk is now based on the fact that I've now come at this now from completely the other angle. And to be clear, whilst I celebrate the tech and I'm really excited by data science, the thing that I worry about and the thing that my teams worry about ironically isn't the last thing on the table is the data science and the data engineering. The first thing on the table is the users and the population. Otherwise, basically, I don't want to go back there again. That was horrible when it happened. About the same time, different sector, nothing to do with me, GM foods turns up, we have genetically modified foods, and guess what? They got torched in the press. So, question mark, why did the science guys not actually explain themselves properly? What went wrong? And I'm not intending to get into this, but I'm just putting a marker down that it went wrong for another group of scientists as well in this space. So I'm going to come forward to this year, and I've called it coming in from the cold. We've had Nazi bots, so we've had IBM Watson stick their self out there on Twitter and then wonder why within 12 hours they get gamed and become a Nazi bot. We've had Cambridge Analytica very recently, and we still fundamentally as a society, if you like, have a perception that this is a bunch of spooks doing clever shit that nobody knows anything about. And we've got to change that. We have to change that, because if we don't change that, we'll all be having a GM Foods, or we'll all be doing what I was doing in 2008, 9, 10, which I don't really want to go back to, okay? So this matters. It really matters. And what I'm going to try and do in the talk today is to approach the problem from a couple of angles and talk about how we solve it. There's another thing that's going on in the market as well at the moment, is the overhype on artificial intelligence. I don't know if you spotted, I haven't actually used the word artificial intelligence until this slide, because I absolutely hate the term. So you'll hear me talk about machine learning. That's my background anyway. But artificial intelligence, if it's intelligent, tell me which bit of it is artificial, and why is it artificial? I don't even understand what artificial means in this context. And we have lots of really interesting products, don't get me wrong, and they do some really interesting speech recognition and all that good stuff, but which bit of that is artificial? And the issue I have is that in the market, and I spend my time talking to customers, they say, oh, what we need now is artificial intelligence. And I was like, okay, cool, what does that mean? What it fundamentally means is a bit of speech recognition, probably. So I'm like, well, okay, so let's not call it artificial intelligence, let's just say what you need is a bit of speech recognition. Let's talk about how you might want to use that, and is that valuable to you as an organisation and your customers? And then I pulled this off. You see, you get Daily Mail headlines. This is from September, warning that artificial intelligence poses a greater threat than terrorism. I mean, I know, okay, it's the Daily Mail. Okay, I'm sorry guys, I used the Daily Mail, but my point here is, again, we run the risk of the media taking us apart with headlines like this. Seriously not helpful. There's an interesting one as well on us as an aside. There's a Harvard Business Review study that you may have come across from last year, where they asked CEOs their confidence in, did their chief marketing officer deliver value? And it only came back that 20% of the CEOs thought their CMOs delivered value, 80% said they didn't deliver any value. You ask the CEO the same question about CIOs and CFOs, and it comes back completely inverted. Well, 90% deliver value, 10% don't deliver value. And it tells you a lot about potentially the overhyping that's going on in the marketing space, and it's the digital space that we operate in as a firm. We've got a problem here, because overhype also leads us to bubble and burst in terms of PR. So the question I'm posing today, that I'm going to try and seek to answer for you guys, is how do we engage the population on machine learning? Given that, they probably don't even know what it is, and they probably don't even care. And we're going to try and force some technology on them. And I'm going to suggest that one of the things we need to think about is how do we do research for user need at scale, and how do we do positive engagement so that it's not an assumed need. It's all too easy to assume a need rather than actually going and talking to people and engaging the population, engaging the media. Is this something that's valuable? So I'm going to break my talk into 4 areas. I'm just going to cover off addressing assumptions, how do we understand user need, applying user need to machine learning, and I'm going to give 3 examples, and then I'm going to focusing on the maths of the research, question mark. That's my throwaway for the end of the talk. So if I look at assumptions, one of the assumptions here is that we have highest paid person's opinion. We call this hippo in the world we live in. We hate it with a passion. because what tends to find in lots of organisations is that they assume they know what their users are doing, and they assume they know what their users want. And now, one of the techniques we deploy regularly is things like going and doing surveys, going and doing guerrilla testing, and this is the bit where we get the data science stuff, so that's getting really interesting. We actually go and look at the data that the users have created over a couple of years, and say, are we seeing the same responses from the questionnaires that we send out to the way that the data works? And what we're trying to break is highest paid person's opinion. Now, when you take that at a society level, you have to ask yourself the question, how do you engage the media to also get involved in user needs research? Because it's not something we do at the moment, but potentially something we might want to do. How does that work? The other assumption here is that users understand maths. Do users understand the implications of maths? Frankly, do they even care? But the key thing here is if what you're doing is you're putting machine learning in to think about automation of what people do on a daily basis, how do you convince them that automation is valuable to them or is seen somehow as a negative to them? And what sort of response are you going to get collectively from society when you do that? And the third assumption is that users care. I think I've seen too many times that not only do they not care, they feel disenfranchised. That's that scary subject called maths over there, but it's having a profound impact on my life and I don't understand it, and therefore scary thing, don't understand, I'm going to have an allergic reaction to it. So what do we do as a society to solve that? So, how do we understand user need? The crazy thing here is it's not rocket science. Dave, this is really for the benefit. Any government people in the room? Have we got any other government people other than Dave in the room? No, this is the benefit of this. The British government has the GDS Service Manual, Government Digital Standard, and their service manual actually is pretty good at describing how do you do user need, how do you go and articulate it. And the thing on the left-hand side is a straight copy from the web of how you do user need, how you write down somebody's user need. One of the things at the moment that's missing is an understanding of learning over time. So one of the very simple but hugely profound ways of rethinking user need, and that's what the additions are and the red ovals, is to add one line in there which is and learn to, what does the user want to improve over time? And it sounds really simple, but actually, if that's the beginning of the process by which you engage society and technology, and engage society specifically in how we think about machine learning, this is the thing that allows you to actually create that engagement with real things and real customers. And the example, I've just worked the example down at the bottom, so that the example is, as a British person, I need a passport, particularly given Brexit, so that I can travel abroad and prove my identity, and learn to get through passport control quicker. So here I'm trying to articulate what is it the user is actually really wanting with their passport. They don't want to be delayed when they go through a border. So actually let's unpack that. Let's unpack the learning that goes on over time. So now I'm going to give a slightly different example, but again it's user need focused, and it's now adding machine learning to having articulated user need. You add the machine learning into how the user experience works. So for those of you that know EasyJet, EasyJet have had a page where they try and advertise all the different routes that you can go on and all the different places you can fly. And frankly, most low-cost airlines do this really badly because it's just a route map. And there is a user need for people to want to be inspired to go and do stuff new. And so all we've been doing is prototyping some machine learning about how people are using the site, how they're using their flights, how are they thinking about going on holiday. And then you link that into a redesign of the web page, and it's called Inspire Me, you can look it up. But what that does is completely change the experience you then have with EasyJet about actually being inspired to go and book your city break to a new city like Budapest that you may never have been to before. The key thing about that final slide is it's relevant to you as an individual. You've logged on, so it's part of your profile within EasyJet, but it understands that there is that you as a person have had a set of things that you are doing, and it's actually presenting that science through content to a way that is meaningful to the end user when they come to wanting to go and have a new city break somewhere else. Okay, there's just one example of how you then take it further. We talk a lot about openness and transparency, and I want to pose some questions here about openness and transparency, because we have obviously the ODI in the UK talks about open data, and okay, great, not quite sure what that means, and it's a good lobby organisation for government, and it's great that they're putting the message out there, but what does it actually mean to us as a society, and how do they engage the media in that conversation? Separately, we have Ofgem creating an environment where Stephen Steer at Ofgem would say his vision for where he's going is that this platform revolutionises how governments do consultation processes. So instead of it being we send out a consultation document and you respond with the document back, as part of that consultation exercise, you have access to the data platform with the entire national data set on it, and you peer review the maths that has been suggested by the department with your own maths checked in back. Now that's a revolution, but it is, and this comes back to the openness, it's about being open with what's available and what governments and societies are working with in terms of data. And that's the thing, I think, when we start talking about openness and transparency, what do we mean? When we talk about black boxes and white boxes in terms of machine learning, we've got to get away from black boxes. We need to be completely transparent. This is just a learning algorithm that can only learn on the stuff that it's been given, the training sets and the like. Is it offline learning? Is it online learning? If we're not transparent about that, we can't create the openness. I'll put it another way. We have to explain feedback loops. If we have data that we're using to train things, that's going to create a feedback loop. How do we articulate that feedback loop for a Daily Mail headline? And Jason sitting in the room will laugh at this one. So how do we explain error to people? I've randomly pulled up a UCL slide which is Higgs, the work on Higgs. Okay, it's great. It's got error bars all over it. Love it. Try putting that picture into the Daily Mail. How do you explain a black swan event? That happens to be an aircraft data, but how do you explain black swan? How do you explain the fact that you may actually change public opinion very profoundly in terms of their appetite for risk on a black swan event, but then you have to explain that black swan event you couldn't have predicted because you've not had the data point to do it. So it's all about what is test and learn, how does that look like, and how do you explain that we're not going to get it right? Machine learning algorithms are not going to get it right most of the time. When we had enough data in them and we trained them enough, we might start to edge towards getting it right. That's a real challenge. And if we can't explain error and we can't explain black swans, this is a really difficult conversation to have. So I'm now going to change it a little bit because I'm now going to talk about 3 case studies. So, and this is a case study on the Office of National Statistics with Dave. So I'm going to sort of big up Dave here because the 2016, Charles Bean did a report, and it's 5.39 is the relevant one. And Charles Bean basically comes out with this statement that they have 12 rounds of audit process on the admin data. Only the first 2 add value. They then have 10 QA points. So this is horrendous. From an ONS perspective, you're now adding humans to add error into a process that's basically broken and is costing the ONS a fortune, both in time and in resource and everything else. And the thing that, and this is where I give a lot of credit to the Office of National Statistics, they took this report extremely seriously and they started to do some very profound things to how they operate, and Dave's going to talk about it more, I know, after me. But let's talk about address matching, just basic address matching. So basic address matching pre-2016 was done manually. So we put in some basic conditional field stuff, and it's great. we've got some offline training going on. We're getting the matching up. The wider question when we got involved with ONS was, do we even know what the 97% that you say you're going for is a 97% of? So even within the ONS, we couldn't get the definition of what was 100%. You're telling us it's 97% and we need to improve it, but we can't actually bottom out what is 100%. And the key thing with address, of course, is it's the difference between what you know and what you don't know. So you have to articulate within user need, again, that there is a body of data that you have that you can train on, but there is going to be data that you don't yet have. This is coming back to the Black Swan event. That is the address that you don't know about and nobody knows about. So how can you know about it? But within the context that you do know, then how do you measure success? And you start putting in offline training. The next step after this, of course, we got, I think when we stuck the offline training in, I think after about 8 weeks we had 99.8% of a redefined measure. That's good. That last 0.2% for the ONS matters. So then what you do is you say, right, well now we need to engage the old members of staff, the admin, they're called admins at ONS, we need to engage them to train in an online way. So now as the admin staff are getting involved, their knowledge is being encapsulated by the maths and the learning in the background so that in the long term that member of staff no longer needs to do that activity. So now I'm creating a problem. So the very person I'm asking to give the body of information to this computer is the very person I'm about to do out of a job, because that computer is going to learn all the various permutations and then they're going to find themselves out of a job. So what does that do ethically? How do you feel about that within ONS? How does ONS deal with that in terms of retraining? Oh, and then the other problem is, of course, because we're affecting national statistics, it has to be perfect when we launch. And we all know there's not a single machine learning algorithm out there that's perfect on the day it launches. So how do you square that circle? Not trivial. And this really comes back to, if you want an engagement of an organisation and you've articulated user need, that's all very well, but if as part of that user need you're making those very users redundant, how does that work? By the way, I don't have any answers for this per se. I think we have to think about how we address it. Right, I'm going to go sideways. This is a completely different example. I feel quite privileged actually to be doing this. I believe, if I'm led to believe, this might be a world first for a car maker anywhere in the world. The thing I'm about to show you is in Norway, you can now buy and finance a car online in 3.5 minutes without going anywhere near a dealer, and you sign the contract and you start the direct debit payments. And I'll just play it and show you how it works, and then we can talk a bit more. Good, there was some really bad Eye of a Tiger track, so I've got rid of that. But this is basically an online journey in Norway. Now, Norway has some huge advantages. They have very strong identity management, which makes this infinitely more doable than other places on the planet. The UK in particular, which has a bit of a disaster when it comes to identity management. But this is them now selecting a car, as you would expect. This, by the way, went live 2 weeks ago in Norway. And there's going to be a promotion next month, which involves the IGO, the one that you've just seen. So they're selecting the colours, types of things they want on the car. And the thing that's the real challenge for us in this, as this plays through, is because nobody's done it, we've guerrilla tested this with tame consumers. We have no idea how this is going to land in Norway, none whatsoever. The dealers are very much involved in what we're doing because the dealers are still owning that relationship once you've actually purchased the car. But the idea of you sitting in your living room at home and purchasing the car without going to the dealership is really profound. You still want that amazing experience and that human touch once you've bought the car. But this is the bit that gets you to buying the car without going there. Now, how does the public respond to spending a lot of money without talking to anybody? You know, how real is that in the new world? I don't know. You know, nobody knows. We don't know whether people trust the internet enough to spend 20, 30, 40,000 pounds on a car without going and talking to somebody. So this is now the finance mechanism. So you've selected the car, you've got a price, and you've got a deposit that you're putting down, and obviously you've got the terms and conditions and all that good stuff. And then it goes into something called the finance calculator, where it gives you your repayments a month, which is, so here we get the repayments a month coming in. And then we get into, you say, okay, great, that's what I want. I've got the right finance calculation going on. Then I pick my dealer. So this is about now being really clear that there is somebody, there's a human going to be involved in it. So we're not taking the humans out. We're potentially reshaping how a dealer operates. It also allows the dealer not to have too much stock. They don't need to have the big showrooms of the old. They need an experience centre to get people excited about cars. They don't need to sell cars in the traditional way, because frankly you can do that at home. And now you get into your identity management, and the identity management in Norway, as I say, compared to an awful lot of countries around the world, possibly with the exception of China, is easy. Yeah, I was going to say Britain is definitely one of the worst for identity management. Yeah, come on. And the thing here is, what then happens is it gets into an identity within Norway, and then it goes into an e-contract. And I'm not going to run this too long. I'm going to let it go to the e-contract. Here we go. So bank ID is the mechanism in Norway. It's basically your social security number and your bank IDs are all linked together anyway. So it makes life very easy. You stick your bank ID in, you go. What's going on in the background now is credit checks and getting your finance details sorted out. And then you're into actually signing a contract, and it should pop up. Yeah. There we go. And then we get into the contracting side of things, and then this launches. It tells you exactly what's going on in terms of how much money you're going to end up paying over how many months. And then you get into e-signatures on a contract. And I'm not going to bore you with e-signatures, because I'm sure you guys all know e-signatures, but effectively you then sign a contract. The key thing that happens at the end is that you then have a real human engage with you as the dealer. But one of the questions we've posed inside Toyota for this is, we've been watching, as part of our user testing, we've been watching how eyes move. So one of the questions we've asked Toyota is, well, given the fact that most of the delivery of this new digital service in Norway is probably going to be on the mobile phone or on a tablet, and it's probably got a camera, front-facing camera, why can't we deploy the eye tracking stuff that we've been doing in the guerrilla testing space to real users and understand how users actually look at pages and how they look at cars online, because we don't understand how people really look at cars online at scale. And how does that help? Now that has all sorts of ethical questions, and how do you tell somebody that as you're looking at the car, you're going to be looking at them looking at the car? We haven't gone down that route with Toyota, but it is one of the possibilities you can do. But how far do you push it? At what point do you say, no, we're not going to do that because we just don't think it's right? Or do you test it and then get burnt? The other struggle in here is that there's an elephant in the room, and that elephant in the room is, if I bought a car online and I then want to engage that consumer in where is your car in the production of it, so it takes Toyota 6 weeks to make a car, where is the car in the production line? Let's say the car's arrived and you then live with the car for 2 or 3 years and you want to engage Toyota in that. All the IT systems that live in Toyota are built 20, 30, 40 years ago. The data that's inside them is not timely and not relevant. It's extremely difficult to then engage manufacturing data sets into telling the consumer about where the car is, and it's extremely difficult to engage old finance legacy systems with telling the consumer how they're doing, what's going on, and can I service you better? So the wider question, and this is one of the big elephants that's in the room in the data space, is how do you convince organisations that they need to upgrade their IT, which has been sitting there for 20, 30 years, given that, you probably can't get the timely and relevant data out of it to prove your point. So you have a chicken and egg with boards. And that's true across the patch. I'll just play you another video, slightly different.
We live in an ever-changing world where unmanned and remote-controlled vessels are becoming reality. Let us share a view of this world with you. The control room is the nerve center of remote operations in the Rolls-Royce OX concept, where the global wall shows a real-time overview of worldwide shipping traffic. A full situation overview is presented to operators who are monitoring vessels via remote link from their onshore workstations.
Dynamic positioning reports DGPS-1. Lost connection for vessel RR9835. Suggested course of action. Diagnostics. Commands?
Proceed.
GPS, geopositioning and celestial navigation status. Nominal. INS status. Transmission stopped. Suggested failure mode, physical. Commands?
Stand by. I'll have a closer look.
Drones 01 through 08 ready for inspection.
Right, that's got a bit Star Trek, okay? That's a video from Rolls-Royce Marine about 2 years ago now. How many people in the room thought that was cool, and how many people were actually slightly scared of that? Hands up who you were scared of it. All right, that's interesting in its own right. So it's great. It's a great PR video from Rolls-Royce. It's amazing what they're trying to do in this space. You can take that video one of two ways. You can either think it's the coolest thing going, that we're going to have autonomous ships that have nobody on them, or you can think it's scary as crap. But actually the question is, how do you take the public with you as you start to push machine learning into these sorts of environments? And I'm going to take my hat off to Rolls-Royce to a certain extent here, because one of the key things they are trying to do is introduce it just in the advisory space to start with. So they're not taking anybody out at all. They're just providing advisory around the sides of the humans, because they need to get the buy-in to the way the machine learning works, and they need to train the algorithms. But having done that, they then have a very clear path to say, well, actually, once we've got that, can we do remote control of the vessels? We still have people involved, but they're not necessarily on the vessel. And of course, the final goal is to go autonomous. But actually being clear about the strategy that you want to deploy on how you are putting machine learning algorithms into things and learning and how they're learning is seriously important. And the picture behind that is their first it's a customer experience for advisory. So that's an advisory centre that Rolls-Royce have in Norway. But it is about having that public discourse about what does this mean to society. Now, the reason I've picked autonomous ships is because there are other very profound implications. And one of them is that ships move between national territories into this thing called international waters, and international waters, therefore, by definition, is governed by the United Nations and an organisation called the International Maritime Organisation. And the International Maritime Organisation then has local sort of government equivalents. So the Maritime Coast Guard Agency is the one in the UK. But the UN, like all governments, is lagging behind the data conversation. So the UN has no understanding of what data is and doesn't really have a body that understands what data means. So we're about to think about sending ships autonomously across the high seas. Who governs what? Do the Americans govern it? Do the Chinese govern it? Do the British govern it? Europeans? Who's governing the data that's coming off that vessel and controlling that vessel and ensuring the collision avoidance regulations are adhered to on that vessel? What happens? Does the UN even understand the word data and what the implications of machine learning mean for the way a vessel moves in international waters? I suspect not. Oh, and then there's this other minor problem with all old legacy vessels, is that there's 40 years of sensor design. And guess what? Every single one of those sensors that's in a vessel has probably got a low pass filter in it. It's probably got some anti-bounce characteristics. It's the sort of stuff I was doing 25 years ago. It's great, but from a data science perspective, I've now just taken out all the noise because I've got a low pass filter on it. So actually, if I want to do real data science in a ship environment, I'm going to have to redesign every single sensor on that vessel. Not trivial, because the supply base doesn't give you sensors now that are just the raw data. It's got all sorts of clever stuff on it, because that's where the market has gone over the last 20 years. So this is not it's not an easy problem to fix. And it's got some profound implications right in the detail of a vessel, but also right up at the UN and saying, how do you manage data internationally, given that internationally nobody seems to talk about it? If I just come back, actually, I'll just jump back one. It is worth saying, one of the things that, and I'm going to take my hat off a little bit to the DFT for this, so one of the things the Maritime Coast Guard Agency is doing, there's a couple of ports in the world. Port of Southampton has just been designated as the trial port for autonomous vessels in the UK, and it's a combination, there's an MOU out with Svitzer's and Rolls-Royce Marine and others, where they will, and associated with ports, where they will actually go and try this. It's going to be really interesting to watch what happens and how the public responds to vessels, frankly, that are in the Solent amongst all sorts of pleasure craft, including myself, sailing yachts around there. How does the public respond to vessels that don't have anybody on them? The other ports that are doing it are places like Rotterdam and Dubai, Singapore. But it's interesting from a UK perspective that Southampton's been selected. So just going to finalise really, and this is conclude where I'm going to try and provoke a conversation about research in the math space. We have models of adoption of technology. They exist. There's technology adoption models have existed for a long time now. There's loads of research from the 90s and early noughties on this. There's a conversation to be had around what's the effect between media, governments, users and tech companies. There are stacks and stacks of research. Great. If we come back to machine learning, which is what we're about today, I don't yet find anybody that can give me, I would love to be corrected by people in this room. I don't find anybody that can give me a system dynamics model of the learning and adoption cycles for technology that is specifically being targeted at machine learning. Because it's one of the big profound changes in society, I would suggest, in the next 20 years. Why do I want a system dynamics model? I want a system dynamics model because then I can start doing scenario planning. I can start understanding, have we got our media messages right, and do we need to do more media messaging? Have I got the right engagement with global bodies, politics, in order to make sure that when machine learning really starts to take off and have a profound effect on society and people's jobs, that we actually catch that and work with it, rather than it being seen as something that gets spat out at us. So if somebody can come up with a system, I'm an old engineer at the end of the day, so if someone can come up with some sort of non-linear system dynamics model that allows us to sort of scenario plan on how this is going to play out globally. I am minded by the fact that the Chinese have a completely different regulatory structure to the rest of the West in particular. There's a great example at the moment in the automotive space. The Chinese government have mandated that every electric vehicle that gets sold in China, 300 sensors a second have to be backhauled. Now, that's going to give them a body of knowledge, which means they understand every vehicle in China. That's not something that happens anywhere else. So I'm going to suggest China might steal the march off us a little bit because they've started to understand the data. So their government is going to be much more attuned to how this works compared to some of the West. So, whilst all that system dynamic stuff goes on, frankly, my day job, and I'm just going to go back to it until somebody tells me otherwise, because I don't want to lift my head above the parapet, is I'm going to worry about user need. I'm going to worry about how we make it simple and transparent and show people how does machine learning really work in society. And with that, thank you very much. My name's Dan Klein.
Thanks, Dan. Questions? Yes.
Have laws been defined around accountability for machine learning algorithms? For example, have laws been defined around accountability for machine learning algorithms?
No.
For example, the driverless cars, if we drive cars and we make a mistake, we go to prison if we kill someone. But who goes to prison if a driverless car kills someone because of a black swan event?
Very good question. And no, there haven't been laws defined around that. And in fact, if you look at how cars are operating at the moment, this is why companies like Google struggle with it. This is why there's that infamous case recently of that lady who was in a driverless car, but of course you are required to still be fully attentive to that car, and she didn't, and she hit a cyclist and killed them because the car didn't recognise the cyclist as a cyclist. It's the way of the world. My career also, I didn't allude to it, but I've spent quite a lot of time in the automotive industry, and the automotive industry is interesting because it's a heuristics problem that's huge, because tyres, roads, if you look at planes as an example, planes have trained pilots, the airports are predefined, three-dimensional fluid dynamics frankly is relatively easy comparative to cars. As soon as you move into the car space, I have a road, the car may or may not be on a road, I don't know what the surface is, I don't know what the weather conditions are for the surface, I've got a driver that frankly isn't trained and could do anything with it, and they can modify the vehicle as well without any control. So suddenly the car industry actually has a really interesting problem, and the autonomous vehicles is really bringing it to the fore because it's such a huge n-dimensional problem that I think it's going to take a very long time for truly autonomous vehicles to happen, because you'll have black swan events, there'll be a major death, that'll cause a PR backlash, and then all the work has to retrench. I mean, it's like the Challenger disaster to a certain extent. If you go back, the Americans shut down their space program on the back of it pretty much, and it's taken them 20 years to rebuild it. We've got similar problems going on.
I guess another challenge is also security, in the sense that these systems, if everyone has this wonderful machine learning technology, and the data is used all the time and transferred back and forth, there's also a challenge onto data security, and how do you manage that?
Yes. Yeah, and I tend to avoid data security questions.
That's fine. We're anyway running out of time, so
cool.
That's a good, on that note, let's thank Dan again.